Hi everyone, this video is going to be a quick overview of what stirred tank bioreactors are before we get back into looking specifically at the Pluri Bioscience bioreactor. And I want to create this video because stirred tank bioreactors are the industry standard right now, both in the pharmaceutical industry and also they're just being ported over in a sense to the cultivated meat industry. Now, I did imply in an earlier Pluri Biosciences video that anyone using a stirred tank bioreactor wasn't going to be successful. I think I probably implied that. I didn't mean to imply that because really the goal is to create a product using the right bioreactor for the type of cells you're using and to make it cheaper than the pharmaceutical alternatives. So that's really the goal for these companies. In this video, we'll get a bit more of an understanding what some of the pros and cons of them are. Let's get into the video.
I am Professor Marloes Peeters and I have different playlists on bioreactors, and in this short video I'm going to explain to you how you can make sense of all of this and how you can select the optimal stir tank bioreactor for your application. So there's different design choices for these stir tank bioreactors, and as I said before, these are the most commonly used ones at the moment and they're still kind of the industry standard. The first one you need to think about is what microorganism I'm working with. And I'm working, for instance, with bacteria that can withstand high shear that actually need a lot of oxygen. Is this a mammalian cell culture? Are you working with plant cells such as fungi? All of this will influence the choice of your design. Then we need to think about the size. So are you just doing this on pilot size, and then are you kind of scaling that up later? And then there's different ways of how you can clean your bioreactor. Probably the most common is still the continuous stirred tank reactor. Here you can generally see what this setup looks like. So you will see you'll have, because it's continuous, we always have things coming in, we always have things coming out. Then you might have a sparger on the bottom if you work with an aerated system. You would have some impellers that create the movement that you need in order to facilitate the transfer between the gas and the vitamins and everything that you have in your mixture. If this is a bigger reactor, you might have like a multi-stage system where you have multiple impellers to make sure that the mixing is sufficient. You might have a cooling jacket, and there's always a couple of different sensors that you're going to use. And also importantly, what you see here is that these reactors are never filled to the top, typically only till about around 70%. And you need that headspace because, as I said, the foaming can be a real issue. So this is your typical design. Let's have a look at what types of stir tank reactors you have, breaking it down into different applications. Now, and this mainly comes back to the fact that you would see the first two really relate to what type of or microorganism you're working with. So if you work with a microbial bioreactor and a fermenter, the conditions are very different. So in this case, you typically have a very high height to diameter ratio because that will allow for more efficient gas transfer. And here, particularly, the anti-foaming system becomes really, really important. Now, what you can see is there's also different impellers associated with this, and some of these impellers generate much higher shear, which you will need to facilitate high gas transfer, whereas other ones, such as for instance your marine impeller, they need less energy input in order to facilitate the mixing. So these are, for instance, more suitable for if you have like a very gentle cell culture system where you can't tolerate necessarily that much shear. Now the second application, so we went from a microbial bioreactor, is then looking at cell culture systems. And here you have exactly the opposite conditions. And the reason for this is that these cells, they don't actually have a cell wall, so they don't really tolerate anything related to high shear that well. They also grow a lot slower compared to, for instance, microbial culture. So if you have E. coli, it doubles every 15 to 20 minutes. So very different conditions. So you want actually really gentle low speed mixing, and your gas transfer can be a lot lower compared to the microbial bioreactors because the energy demand or the demand for the oxygen is much lower because they don't really grow that fast. However, what you will need to do, you will need to have a very precise control over the oxygen because they will be much more sensitive to that. And generally, you would also have different ways of how you would control the pH. So these mammalian cell culture systems are very sensitive to pH. So normally you would have like an acid-base feedback system and a microbial bioreactor. But for instance, here it's much more common to use carbon dioxide to regulate this.
These types of reactors are ideal for growing cells in suspension. Some of the cons, though, for cultivated meat is there's high shear stress, which can damage the cells. Not ideal for certain types of cells. Also, depending on where the cells are in the bioreactor, they may get more or less oxygen. So this is just an illustration of what can happen. It is possible to get these dead zones where nutrients might not be reaching the cells. And that's just important because that would lower your efficiency of production. It means maybe you'd have more waste to get rid of. It means maybe you wouldn't have as many cells growing, so you wouldn't be able to make as many cells for the cost. Stir tank reactors are used today in cultivated meat R&D and pilot plants. The question is, are those types of bioreactors going to make it into the production stage for large-scale projects, or are we going to need to move to other forms of bioreactor designs? I don't know the answer to that question. As we can see from all these companies, many people are experimenting with that. Thanks always for watching. Catch you in the next video.